Taking the case of the velocity, we know that the velocity is the time rate of change of displacement. On the circle of reference, the velocity of the particle executing S.H.M is given by the projection of the velocity vector, that is tangential, on the x-axis or y-axis or on either of the diameters. Let us see that here the particle P has got a tangential velocity of v along the tangent of the circle. Here it is the a, that radius of the reference circle. This angle is omega t, and so this angle is omega t. Now the component of velocity along this y dash is the component of this velocity along this. So the component of velocity v along this direction, because this and this is equal, because these are parallel. So the component of the velocity along this side or on this y dash gives us the velocity, and we can say that this is the horizontal component or the cos component. Now we know that y is equal to a sine of omega t. If initial phase is taken as 0, then the velocity vector is given by component of this velocity vector along this direction or along y direction. The velocity v component cos of omega t. Now we know that v is equal to a into omega, where omega is the angular velocity and a is the radius. It can be given as 2 pi divided by t into a, where 2 pi a is the circumference of the circle and t is the time period of revolution. That means that gives us the linear velocity. So we can say that v is equal to a omega cos omega t. The velocity of the particle executing S.H.M is given as v is equal to a omega cos omega t. Velocity can also be given as time rate of change of displacement. Here displacement is equal to y a sine omega t. So velocity is equal to dy by dt. That is d by dt of a sine of omega t. Taking a out of this because a it is constant, so a d by dt of sine omega t, and we know that the differentiation of sine is cos of omega t, and internal differentiation of omega t with respect to t, that is d omega t divided by dt. That gives the equation a omega cos omega t. So the velocity of the particle executing S.H.M is equal to a omega cos omega t. Velocity is equal to a omega cos omega t at mean position. At mean position, theta is equal to omega t is equal to 0. So v is equal to a omega cos of 0. We know that cos of 0 is equal to 1. So velocity at the mean position is equal to a omega. So the velocity amplitude is equal to a omega, and the velocity is maximum at the mean position. Now talking of the extreme position, at extreme position theta is equal to omega t is equal to 90 degrees. So the velocity at extreme position is equal to a omega cos of 90, and we know that cos 90 is equal to 0. So velocity at extreme position is equal to 0. That means the velocity is maximum at the mean position and 0 at the extreme position. That is why the body doesn't go beyond the extreme position, because the velocity at the extreme position is equal to 0. The vibrating or the oscillating body overshoots its mean position because velocity at the mean position is the maximum. By having that maximum velocity, it overshoots its mean position and cannot stay at the mean position, then goes to the extreme position. At extreme position, the velocity is equal to 0. That means it can't go beyond the extreme position. That is all about the velocity. Acceleration can be given as double differential of the displacement or the single differential of the velocity. Now we are aware about the displacement equation as well as the velocity equation. The displacement equation is given by y is equal to a sine of omega t, and velocity is given by a omega cos of omega t. Now the acceleration is equal to differential of velocity, that is dv by dt. That means d by dt of a omega cos of omega t. Now acceleration is given by a omega is constant, differential of cos omega t is minus sine of omega t. Now the internal differentiation of omega t is equal to omega. So acceleration is given by minus a omega square sine of omega t. We can also take it as a sine omega t. This a sine omega t is equal to y. So acceleration is given by minus omega square y. At mean position, y is equal to 0. So a is equal to 0. At extreme position, y is equal to a. A is the amplitude, so the acceleration is given by minus omega square a. This states that the acceleration at the mean position is equal to 0 and acceleration at the extreme position is equal to maximum. What is the acceleration? Acceleration is the time rate of change of velocity. At mean position, the value of the velocity is maximum, and we know that the differential of maximum and minimum is equal to 0. When we go to the extreme position, at the extreme position, the velocity is equal to 0, but the acceleration is maximum because at the extreme position, the direction of the velocity is changing. The body is going from mean position to extreme position. At extreme position, the direction of the velocity is changing, so the acceleration is maximum at the extreme position. At the mean position, the velocity is maximum. That means the time rate of change of maximum value is equal to 0. So at the mean position, the value of the acceleration is equal to 0. As we know, the differential of the maxima and minima is equal to 0. This minus sign tells us about an important thing, that the acceleration is always opposite to the displacement. That means when the body leaves from mean to extreme position, the displacement is in this direction, but the acceleration is in the opposite direction. As it goes from the mean position to another extreme position, the displacement is in this direction and the acceleration is in this direction. So acceleration is always directed in opposite direction to the displacement. Talking of the time period, the relation of the time period can be got from the relation of acceleration. The magnitude of acceleration is equal to omega square y. This minus sign tells us it is always opposite to the displacement. Now a is equal to omega square into y. I can say that omega square is equal to a divided by y, or omega is equal to root of a divided by y. Now omega is the angular velocity, so it is equal to 2 pi divided by t is equal to root of a divided by y. Rearranging it, we get t is equal to 2 pi root of y divided by a. T comes here, this comes here, so the relation becomes t is equal to 2 pi root of y divided by a, or time period is equal to 2 pi root of displacement divided by acceleration. This is the relation for the time period of the simple harmonic motion. Hope you understood.